Hi, I am Dr. Itara Antamarasin. Welcome to Object-Oriented Analysis and Design course. The course is part of Software Engineering Program, School of Engineering, KMITL. In this course, you will learn how to design software system under object-oriented concepts. We will focus mainly on the designing and not the development, so there will be no coding involved. Still, the course will be practical. You will design a software system just like in the real world. We will start from gathering requirements, conceptualize the software, designing the user interface, user experience, as well as software components, again, under concept of object-oriented design. Since some of you are still doing internships and some are still abroad, this course will be divided into two parts, the video part and the on-site part. The video part will cover lecture 1 to lecture 6 from July the 3rd to August the 11th. The contents will cover most the basic knowledge in the video part. Then after that, we will see each other on site and we'll conduct some practical exercise, the lab sessions together. More on that at the end of the session. This is our course description. Well, it is written in your syllabus. This course covers the principles of methodology of object-oriented analysis and design, with the emphasis on the use of the Unified Modeling Language or the UML, and also the object-oriented development methodology under the Unified Process. Students will study how to utilize various UML diagrams as well as several design patterns in software analysis and design processes. Well, it is long, it is boring, it is in syllabus, nobody read about that. But let me get you the main concept, the most important thing that we are trying to achieve, okay? Not just in this course, but the entire software engineering program. You want to build the right thing, and you want to build the thing right. But before we discuss both points here, the right thing and the thing right, what exactly are we building? Of course, this is software development. You need to build software. Yes, but hold on. See, the screens that I show you right now, all right, they are all software. Okay, you have a social media platform, you have data visualization, you have email clients, you have games. Okay, all these are software. But what are they exactly? What are they? What is a software? Okay, a software is a solution to a problem. Take a look at this screen in the front. All right, this is the data visualization, okay, from the World Health Organization of the number of the COVID-19 patients across the globe. All right. Well, if the WHO asks you to develop the software, this piece of software for them, okay, well, you might need to make sure that you understand them correctly. What kind of data are we presenting? To whom are we presenting? What kind of platform are we presenting? All right, and this is the constraints of the solution of the problem. The problem is to present the data, maybe to also to obtain the data and to present the data. That's the problem, and your solution is the platform that can collect the data and process the data and show the data somewhere, maybe online. All right, but you need to understand where did they come from, who are the audience, how does it look like, and so on. Okay, well, and that is one of the example. Another one is the social media. Of course, social media solve problems too. Social media solve socializing problem. We all want to connect. Apart from just the local area or local pubs, local bar, the families, friends that we know. Okay, we want to connect further. We want to connect to everybody in the world. Okay, it also creates a lot of new businesses like content creators, influencers, and so on. Also, the last point I want to make here is game. All right, games solve problem too. All right, we are bored. Okay, we want to kill some time. We want to entertain. We want to enjoy ourselves. It also again create a new entire market. You can also stream on Twitch, Facebook, YouTube, whatever platform you like, and also earn money too. All right, but business aside, let's talk about the game and then the entertainment aspect itself. Okay, I find game development very difficult, like extremely difficult, much more difficult than this one, okay, than the dashboard. I would even go further to say that game development, if you were to make sure that it is fun and it can run on every platform, it is also more difficult than most of the online solutions or online services that we have. Why? Because first, game design. Everybody wants to be a game developer. Maybe some of you do, right? But in order to make sure that the game sells, people like it, you need to design the game that is engaging, that is fun, that is pretty, beautiful, all right? But not just that. Apart from fun, you also need to make sure that your game runs. It has to run nicely, doesn't just exit itself every 5 minutes, and it also has to run perfectly on all platforms. Okay, Xbox, PlayStation. Well, Xbox and PlayStation. These platforms are easier to develop because you know precisely how the hardware look like, right? But for PC games, these are difficult because you don't know the configuration of a user. It could be anything, different kind of graphic cards, different kind of CPU, different kind of memory, different kind of hard drive, and so on. All right. So game development is very difficult. You need to make game fun, and you have to make sure that the game performance is also very good across platforms. Now, building the right thing. Okay. In order to make sure that your software solve problems correctly, solve your users' problem correctly, you need to make sure that you understand your users correctly. Okay. But before we go on to that, let's just introduce the two words that we are going to use a lot in this course and also in software design process. Users. The users are the ones that use the product. In contrast to customers, the customers are the ones that pay for the product. Okay. Well, I want to make a large distinction here. This distinction here. The users and the customer could be the same guy if they pay and use the product, but sometimes, especially in the enterprise software, the one that use the product are not the one that pay for it. Okay, for example, the executives, the management wants to install a new software to manage the sales management or to manage the some computer data and so on. All right, so they employ a software, and then they implement the software and use it in the company, but they're not the one that use it. The ones that use it are the employees. All right, that the users are the guys that in the cashier or the guys that are that do accounting and so on. So, and sometimes when the customer look at the software, look at the spec of the software, talk to the salesperson, they think the software works, but the user doesn't like it. All right, because it doesn't solve the user's problem. So you need to make sure that when you develop a software to anyone, all right, especially the big in the big organizations, you want to make sure that you talk to the user directly. You don't just talk to the customers. You not just talk to the one that can sign off or can agree with the project. Okay, you need to talk to the user. You need to understand how the user works. You need to understand how the user behave and what they actually want. All right, and we're gonna talk a lot more about this concept. Okay, so once you understand what the user wants, how they behave, how they work right now, and how they will work using the software and so on, then you can make sure that the software that you are going to develop does solve their problem. And this is what building the right thing is. You build the software that solve the problems of the users, maybe the customers too, okay, if it works, but mainly the users. and you deliver the software that not just solve their problems, but that make their life also easier. All right, it had to be suitable for the user as well. Now, to build the right thing, well, it is a little bit more complicated than just to solve user problem. All right, here we are focusing on a few questions as follows. How can we deliver the right product? Of course, we want to deliver the right product. We want to make sure that the users are happy, that our software solves their problem. But how can we do it? Okay, what is the process to make sure that what we do corresponds to what the user needs? That is, we need to understand our users. How do we understand our users? What do they want, and why do they want it that way? Okay. Also, we would like to make sure that we can develop our software in time and in budget. How can we do it? All right. After we deliver the software, okay, we want to make sure that our software is easy to maintain and easy to upgrade. If there are some bugs, it can be fixed quickly. If the user want to change something, or the users want to add something or remove something, we want to make sure that our software can do that easily too. Remember, you don't just deliver the software, but you need to keep maintaining it as well. Then, after you understand the users, okay, after you have your software model, you have your design, you need to communicate what you know and what you learn to other developers and users as well. So you need to find a way to convey your knowledge, or convey what you want, convey your model to the other guys, all right, to your team, and also to your customers and to your users, so that everybody is on the same page. And in this course, we will learn to do that as well. Before we start building software, let's just get some example. All right, get some ideas. Let's talk about building a house. For example, okay, you're a customer. You want to build a house. All right, you have a vision and you have a budget. You want to build a palace that is gold and it sits on the lake like this, right, in the picture here. But you don't know how to do it. Okay, you just have the idea, you have the concept, and of course you have some money in your pocket. So you're gonna need the builder to carry out your work, to carry out your vision, to realize your vision. Right? But before the workers or the builders can do the construction, you're gonna need to hire an architect to transform your vision into a building plan. You might want to find an engineer to transfer the vision of the architect into the actual implementable building plan as well, before the construction workers can actually carry out the work. In software business, all right, to build a software, we have the similar structure. Okay, first we have the owner. Okay, we call him product owner. The product owner has a vision, or problems that need to be solved, and he of course has some budget, has some money in his pocket. All right, usually the product owner has some specific budget, like, okay, I can afford this much, I can't just go beyond this. All right, and he has to accept the written software, but we're going to come back to this point later. And then we have the system analyst. Okay, system analyst does the planning. He has to capture the vision of the product owner. Okay, you want a castle, you want a big house, which is gold next to a lake. Okay, how about a garden? All right, he has to capture the vision and comes up with a building, a construction plan. But before he can do that, he has to understand all the details. Okay, how many people going to live in the house? Okay, how many bedroom you need, how many baths you have, how many baths you want, how large is the living room, how large is the kitchen, and so on. All these requirements, all these needs from all users must be understood. Okay, before he carry out the plan. But well, just to be clear, In agile development, some of the details can be understood later during the construction as well, but we're going to come back to that point. But the idea is that system analysts must understand the detail and come up with a plan. Okay? But there are a few details that we need to discuss later during the course. And then he has to define solutions. Okay, basically he has to develop the plan or construction blueprint in the, such that the construction workers can carry out the work. Okay, and he has to check whether the written software satisfies the vision. We're gonna come back to this point later as well. And the process of doing this analysis is system analysis and design. Okay, system analysis and design process. Now, once this process is done, you're going to have the construction workers or builders or programmers that develop the house or the software, okay, or just to start coding. Sometimes they are architects themselves. What do I mean by that? See, traditionally, we have system analysts and programmers separately. Okay, you have a team of analysts and you have a team of programmers. And when the analysts finish their work, okay, here's a plan, I understand the vision, I got the plan, all right, everything should be in budget. Now you start doing the work, start coding now. And we have another team doing this. But recently, in the last 20 years or so, we moved from this separate structure into a combined structure. So one guy does everything. All right, he has to understand the user. He has to come up with a plan. He has to understand the big picture, the detailed information, and then he also has to code as well. This shortens the development time. You don't have to wait for this guy to finish so that this guy can work. All right, you can just design a little, start working on it, showing to the customer, do they like it? All right, if they do, just go on to the next component, and so on and so forth. All right, and this concept builds up into what we call agile development today. But we're going to discuss more in detail during the course and also in the next course, the next semester, software development process. Now, when the programmers finish building the software, okay, either the entire software or part of the software, he has to discuss with the system analyst. This guy is going to check whether the software that is built correspond to the plan or not. Okay, and the plan, of course, has to correspond to the vision that the owner has. Now, after the software is mature enough, okay, you can show the software to the product owner. And the product owner is going to say that, okay, I like this or I don't like this. He can accept or reject the project. Well, he is the one with money, so he decides. Okay, well, and you can see that this could be disastrous. All right, you spend 5 years building a nice palace according to the vision, but when you show that to the customer, the customer will like, this is not what I want. But we said something like this, yeah, this is what I might want 5 years ago. I don't want it now. Or, yeah, I thought it would look better. I thought staying next to a lake would be cool and nice, but now we have a lot of mosquitoes. Can we move the house a little bit back further to the land? All right. When you build an actual palace, this wouldn't happen. You can't just move the house. But sadly for you, the mindset of the customers when they build software, they always think that software can be fixed. In a way, it is right. They are right that yeah, you can fix this. You can just move the house 10 meters inland. Just a few lines of code sometimes, but sometimes changing small things means you need to change a lot of stuff. All right, you might changing the, okay, you can maybe you custom want to add some fields, add some information or some features, and you just have to change the entire database. You need to change the servers, you need to change the infrastructure. That happens too. Okay, so in software development, we try to avoid this disaster. We try to let the customer involve in the development process as often as possible, as much as possible, so that they can have a look at the and try the product, even though it is in the early stage of the development, so that they knew right then that this is not what they want. Maybe it is what they want, but we can improve in this point. This is confusing. I don't understand this. I don't like this. They can give you some feedback or opinions early. All right. But the idea is still the same. You have the three guys: product owner, system analyst, okay, and programmer. Oh, by the way, product owner, usually we usually use PO to denote product owner and SA to denote the system analyst. Developing a new system is usually done as a project. Either it is a house, a Death Star, or a software. All right, a project is a planned undertaking or a planned operation that has the beginning and the end. So it has a starting point and it has the end point. It also produces some definite result. What it means is that when the Emperor told Darth Vader to build the Death Star, okay, he has a vision. All right, that construct the largest cannon ever built, all right, that can destroy the planet, all right. And when Vader contact his contractor to build the Death Star, he had to define as well that, okay, the Death Star is this large. It has to has this huge cannon made out of this, I don't know, kyber crystal, right? And it chooses the planet, all right. It has to have some definite result what it can do, all right. And then when should we begin the project and when should the project ends, okay. And to manage a project, you may need a project management framework and the project manager to help you through the project. Okay, you can employ the apart from the manager, which is a person. You can use the project management framework to as a guideline to coordinate the teams, how it works, and so on. Documentations during the project as well. Still, even though a project has an end, it means that at the end of the project, if you deliver the result that you promised, okay, you should get paid. Yeah, and usually people do, okay, they get paid. But not just that. You should think of your software as a product, not just a project that when it ends, you get paid and it's done. You can, what do we mean by product? Well, you need to think of it as the something that's gonna grow later. Can we extend that? Can we change it? All right. We're gonna add new features. We're gonna remove some features. We might try to optimize the performance. We're gonna add something inside. All right. You need to think of it as a living thing, a living product that grows over time, that changes over time. Why do I emphasize on this? Because if you don't think of extension maintenance and bug fixing, extending later, okay, if you don't think about that, you might have problems doing this thing later. The infrastructure, the design, okay, from ground up, it has to be able to handle or to accommodate all these changes that might occur in the future. Even though you don't do it right now, you need to keep in mind that, hey, if I do it this way, it might be very difficult to change later. If I do it this way, it might be difficult to extend later. Therefore, right from the ground up, right from the get-go, you need to make sure that your software is extensible and manageable, fixable. Otherwise, you're going to have a lot of problems down the road. So let's discuss what is analysis and design. All right. Analysis refers to the process of investigating the problems and the requirements. Basically, you want to understand the problem, you understand the user's need, you want to understand the customer's need. All right, and not to find the solution. Not yet. Okay, you just want to focus on the requirements. For example, what are the features of a Death Star? How long could it operate? All right. What kind of explosion do you want? What kind of power do we need? All right. How many people should operate there? Should we have the bases there? How many guns do we need? All right. And how many protection system, heating system, ventilation system, stuff like this. And maybe how to protect the plan not to be stolen by some bad guys. All right. So you want to understand all this first before you even start to design the solution. All right. But once you get all this, once you understand the users, once you understand the customers, move on to the next step, design. Designing means to find, all right, a conceptual solution that fulfills the requirement. So basically, you are now in process of getting the solution to the problems. All right, you draft a solution, not yet to implement it. Okay, for example, database schema, object design, user interface. All right, these kind of plans, kind of blueprints will be used later during the development. Okay. So what about system analysis and design? Okay. System analysis is in activities that enable a person to understand and specify what the new system should accomplish. New system means new software system, new information system. All right, what should it do? Okay, to understand and specify what the system should do to satisfy the customers or the users' needs. What to do, okay, not how. But when you move on to the system design phase, system designs are activities that enable a person to define and describe it in detail the system that solves the problem. Yes, to solve the problem, you are now describing the solution, okay, how the system should work. In the analysis phase, we are trying to understand what the system should do. In the design phase, you are trying to specify how the system should do to do this. How do I do this? Okay, how do I do it? How do I do this to answer to this? All right. So these are the two things. And when we design and we analyze the system, I would like you to think of the entire thing as a system. Okay, we are accustomed to the concept of applications or app, which is the program that we use. Okay, I can use my iPhone, I can open Facebook right now, I can open YouTube right now, TikTok, for example. This is just one part of the system. It is the part where the users interact with the system. Most software systems today are online. Okay, well, it sends data somewhere, the data processed here and gonna be stored somewhere, gonna be even processed somewhere else. So I want you to think of your product, okay, your software as an entire system. Sometimes we call that an information system, which is a set of interrelated computer components that collect, processes, and stores and provide the output needed to complete a business task. So basically what it means is that it just doesn't count, it covers everything from the front end to the back end, to database management system, to the file server, okay, to the cluster, all right, and come back and then process something and send the output back to the user, okay, to the front end system. And sometimes you have more than one front end, sometimes more than one client, more than one users, and then all these users sending in data and being processed, being aggregated, and then this data, this processed data will be shown back to the user later. Not just that, information system could involve manual tasks as well. For example, imagine that you're going to 7-Eleven, all right, and the person in the cashier scan in your products, okay, scan the barcodes of your product. That part must be also accounted to the system too. That process of scanning, all right, that process of stock checking, that the process of putting the moving the product from the shelf to the refrigerator or from one shelf to another shelf, okay, has to be accounted as well. And as the developers, we might have to develop an entire information system, not just individual apps, okay, but front end, back end, including how the user or how the person should work to complete some tasks. For example, if the guys in the 7-Eleven want to move product from the back storage to the front shelf, okay, he has to first physically move the product from the back storage onto the shelf and then maybe scan the product or record into the system that, hey, I have moved 100 pieces of Coke from the back storage into the refrigerator. And that process has to be documented, has to be thought about as well. Let's have a look at the entire software development process. You might be familiar with this image already. Okay, this is the software development lifecycle. Right. First, we have the planning. Okay, customer envisions the product. Okay, and he has the question, what are we going to do? All right. Here, the customer would like, okay, I would like to build a Death Star. All right. How much does it cost? How long does it take? Would it worth it to, destroy the entire planet? Well, if it takes like 20 years, maybe we don't need that. Maybe Star Destroyers would do the job and so on. You need to check all these angles. And this is the process. This is the part of process called feasibility check. In feasibility check, you want to make sure that the project, it is financially feasible, personally feasible, all right, and of course, can we do it in time, all right? Now, if the planning is done, okay, you're going to move on to the detailed analysis, the requirement analysis phase. This phase is to identify the problems or needs, okay, what the software is supposed to do, okay, and then you obtain approval to proceed. Now, before we go on, let me discuss with you a little bit more into these points. There are a lot of people that comes to me and ask, okay, I have an idea. I would like to do this platform like Lazada, Shopee, whatever, all right? And they are in the step of planning. They came to me or called me and said, hey, we have this idea. Okay, we would like to know how much would it cost. The first thing I'm gonna ask them if somebody call me and ask me like this is that, why do we do that? Okay, let me get you some concrete example. There is a guy called me several years ago. He has an idea, okay, that he is going to do taxi service like Uber, okay, and grab car. So he called me that, okay, I have the network of taxi drivers, okay, that could provide services similar to Uber and Grab, all right, and I would like to invest some money to develop this system. Then the first thing I asked him was, why don't we just use Grab? Yeah, but okay, but if we do that, I will. Well, I don't want to pay. Basically, he doesn't want to pay for Grab. He has the connections, have a network of drivers. They would just like to, keep the profit within the ecosystem, which is a fine point. All right, but I told him that, okay, we might need a lot of money. I forgot how much I estimated. all right, but it's a lot of money. And then, okay, we might need around 1 or 2 years to develop. And I don't think it is feasible. I don't think that's worth it. And after some pondering, he was like, okay, then I don't use it. But then, why don't we do it? I mean, the main reason why we didn't that I opposed the idea was that it isn't worth it. All right, just that we have a set of drivers, we have limited number of drivers, and you want to keep the money among yourself. All right, you don't want to spend for Uber. You need to invest millions, okay, and it doesn't pay off, at least not in time. Uber or Grab, they have a lot of money. They have large investors that can wait years before it actually profitable. I don't even know they are profitable right now, right? But you need to have a big pocket. And as a driver themselves, they can just use one of these services, okay? Because even though they are driving for Uber or they are driving under their own platforms, the driver gonna pay some commission fees anyway. It wouldn't be profitable for the driver as well, and that is where you should stop. In the planning phase, okay, this is the part where you have where you study the idea. You don't have to spend too much time, too much money, too much investment on this. You just think about the idea. You just kind of roughly predicting or estimating how much do we need, okay, to do this, how long do we need to do this, and then, okay, if it's not feasible, then we discard the idea, looking for new some new things to do. But if it is feasible, oh yeah, maybe this would work. The idea is good. Nobody has done that before, and not too much. We can find a joint venture. We can find angels. We can maybe we can even invest in ourselves. Then we move on to the detail analysis. This is the requirement analysis phase, and this phase, you might need to hire system analysts or professionals to discuss with the customers, discuss with the users, what do they need, what do they want, how does it look like, okay? And here you might have some plan, a set of requirements, maybe some UI, maybe some UX design, all right? And to collect the idea to make sure that this is the concrete thing that we are going to do. All right, maybe not 100%, maybe like 30, 40%. And then with this detail, you can start thinking about the budget more precisely. If right now at the end of this phase, you realize that it is not worth it, that it doesn't worth it, we couldn't make it anyway, all right, then stop here. Then maybe you just have to pay the analyst maybe 10-20% of the entire development costs. That's a loss, but not entirely catastrophic. All right. But if after this phase, you say, all right, we're going to do it anyway, I think it's awesome. All right, doable. Then we move on to the design phase. This phase is to discover and understand the detail of the problems. This phase, you are starting to design the solution. All right, you design the components, you design the inner workings, you design the interfaces and how this component works together. And after that, okay, you can start implementing. Once you finish, you do the testing and deployment, and maybe you're gonna come back to requirements analysis again for the next version, next iteration, and so on. And at the same time, you can also you need to also to maintenance the software that you have already deployed and released, okay? And you go on cycle and cycle and cycle like this. Again, this is what we call SDLC, or software development life cycle. Just to summarize, okay, this is just kind of rough idea phase, a conceptualized phase. You can stop here. You don't. Most of the time, you don't even have to pay for anything, because you can just do all the studies by yourself. And then once you do the planning and you think, oh man, it's awesome, we can still do it, then you move on to the detail analysis, the requirement analysis, or the requirement elicitation process. All right, and then you design implementation and so on. You can stop here. You can stop here. You can even stop here. All right. Well, basically you can stop anyhow whenever you like if you just think this is a bad idea to go on. All right. But most of the time, most people stop either here or stop here. So what kind of tools do we use in this requirement analysis and design phases? We use the UML, Unified Modeling Language. It is a visual language for specifying, constructing, and documenting artifacts of the system. So essentially, it is diagram notation for presenting pictures with some text related to object-oriented software. We can call that an OO design tool, all right? But, well, even though it is a diagram, all right, with some notations, it is still language, okay? It is a language that conveys a design, okay, but not the design itself. So it means is that you need to have the design in your head first and use this to describe what you want to do, what you have in your head. And because it's a language, everything in the notation has a meaning, specific meaning. It has some grammar, it has some vocab, all right? If you draw some lines with some symbols, it has to mean something, okay? And in this course, we're going to emphasize on that meaning as well. Well, to be fair, UML is used quite a lot, all right, in the software industry. You might be familiar with the use case diagram here. You might be familiar with the class diagram here, right? And of course, sequence and activity diagram as well. These diagrams, especially class diagrams, is used quite heavily, all right, to explain to describe components, classes within your system. And sometimes you can use this to explain the model to your customer as well, all right? But when you describe to your customers, you might just use some boxes, all right? Simple watch includes 2 buttons, a display, a battery, and so on. You might not need to be super precise. Sometimes you don't even have to be precise, even though you are describing your components to your fellow developers as well, because we all understand each other. You can just use, boxes and lines and so on. But in this course, you have to be precise. All right, anything that you produce in the exercises, in the lab sessions, in the exam, you need to do it correctly by the book, grammatically correct. All right. Well, but really, as long as you can convey your message to your customers, to your developers, to your team, I'm fine with that. Right? And in the real world, nobody cares much about the grammar, but in this course, we do. Right. Okay, so these are the examples. Use case diagram is used to describe what the system can do, all right, in the perspective of a user or an actor. For example, this watch user can read time on the watch, okay, and can set the time. The watch repair person can change back the battery, all right. And the class diagram describes the components. This simple watch composed of 2 buttons, 1 display, 1 battery, and an engine. A package diagram is a group of classes. Sometimes you can put the entire set of class into one package. All right, and in each package can also be related or associated to some other packages as well. Moving on to the sequence diagram. Sequence diagram is the diagram that is designed to describe how messages are being exchanged between classes, how classes send information among each other, all right? And we have the activity diagram that describes the process. You can use this to describe the inner working of your software. You can also use this to describe the workflow of a user. The user has to do this and click that, and then scan with barcode and so on. You can use activity diagram to describe these behaviors. Now, lastly, in this example, we have collaboration diagrams, which is, well, pretty much the same purpose, has the same purpose as sequence diagram, but you are using you are drawing in the bird eye view, so you are seeing things top down. All right, this class interact with this class, which interact with this class, and so on. All right. And we have the message call, right? And the order, step 1 you do this, step 2 you do this, and then step 3 you do it, and so on and so forth. The top part of these slides, all right, these diagrams are static models. So they basically what it does, what it is, okay, how many components we have. It doesn't explain how it works. This is the dynamic. These are the dynamic diagrams. All right. They explain behavior of a system. We're going to discuss a little bit more on that later. UML composed of many kinds of diagrams, all right, and we can divide them in terms of models. Right. First, we have functional models that describe the functionality of the system in the user's perspective. All right, we can use these use case diagrams to describe these functional models. Next is the object models that describe the structure of the system in terms of objects. So basically, you want to explain what the system composed of, what are the components inside the system, what are the subsystems, what are the components within the subsystem. In order to do this, you can use class diagrams and package diagrams to do it. And next is the dynamic model. Dynamic model describes the internal workings or behavior of the system. All right. See, object model describe the components. What are the components? The dynamic models explains how these components work together. You can use sequence diagram or interaction diagrams. All right. You can also use the activity diagrams to do so, or you can use state machine diagram to do so. And we are going to learn how to use this diagram within this course. Lastly, we have system model, which is the combinations of all other models. You use functional models to explain the behavior of a system in the eyes of the user, and you use object models to describe components, subcomponents, subsystem within the system, and then you use the dynamic model to describe behavior or interactions among the components to solve a problem, to achieve the task, to achieve a function. All right. Together, we have the system model. As I told you earlier, UML can be used to describe your models or ideas to the user as well. All right. Well, you can in this case you are using UML as a sketch. All right. It is an informal, incomplete diagrams often drawn on whiteboards or on papers to explore difficult parts of the problem, or maybe to explain the idea to non-technical person. But you can use UML as blueprints as well. It is a detailed diagram that is drawn to visualize and understand the existing code or describe precisely how new system should be implemented, all right, how new code should be written. Recently, with the popularity of Agile method, UML is encouraged to be used mainly as a sketch. See, we don't want to be super focused on the design, then the code, all right? Agile is focused on flexibility, extensibility, and changes. All right, we don't want to bog ourselves down into the design. We don't want to stuck into the design phase. We want to move on. We want to deploy. We want to develop and deploy to the customer so that we can get the feedback from the customer as soon as possible. So we can use UML as the generic tool that describes generic idea, okay, and let the developer solve the details by themselves. Sometimes you don't even need the diagram to explain anything. You can just write the code, explain in the code itself or in the comment within the code. Because simple and straightforward design can be solved by programming. To this point, right, I'd like you to understand that we don't emphasize on the design unless it is complex. I encourage you to write down class diagrams, to write down sequence diagram, if you need to explain something that is complex, like how the API exchanges information, all right, how two components or even more components exchange information, and especially when there's a complex, okay, when you contact the payment gateway, or when you want to create new users with OTP, something like this, some complex sequences, all right, then you need some tools, you need some kind of description, concrete description, so that everybody that is involved in the development understand and are on the same page, especially if they are not sitting in the same room. Okay. Oh, apart from that, remember that once you finish development, you need to maintain it as well. Make sure that whatever you do, okay, either it's going to be simple design, difficult design, you put you write the code or you write the comment, all right, make sure that you and your team can come back and fix it later. Okay, so if things are simple, all right, you write simple solution, you write simple code, the code is clear, you don't even need a comment. But make sure that 2 weeks, 2 months, 2 years from now, when you come back and revamp to refactor the code, you still understand what you did. And if it is complex, if it is a little bit difficult, maybe some comments would help. Comments is always welcome, all right? But if it is a complex task, okay, please do your best, okay, be a good boy and write down UML, some documentation along the after or before or during your development, okay, because you might need that yourself sometimes later. Yeah. So this course is about object-oriented analysis and design, and UML allows the developer to describe things in object. Okay, so the key, before you can do things in object, you need to think objectly. Okay, after well, maybe during the course or after you finish the course, I want you to think of, you see the world as objects. Everything can be defined as classes, as objects. Okay, everything is a subclass of everything. Okay, you just have to find similarities. You need to learn to group things together. You need to learn to separate things together. Each object has attributes and operation. You need to know what it does. You need to know what kind of information that describe this object. Okay, a guy or a human can have eye colors, hair colors, arms, ears. Okay, well, it is enough to describe human. Okay, well, a dog could be a little bit, well, more difficult to describe. Okay, what kind of eyes does it have? What kind of hair does it have? Do you have a tail? All right, and something like this. So you need to learn to add attributes, remove attributes. You need to understand, okay, this attribute is important, these attributes are not important, I want to keep them. And also you need to understand what each object does. Okay, what are their operations? Okay, you need to learn to think objectively. And most important, anything you put into your system, any object, any class, anything that you put into your system that you put in your design, they must have purposes. All right, I don't want you to write some class down, okay, or some attributes down, some operations down, and then when they ask you, why do we need this, you were like, I don't know, I think we need that. But why? What do we need it for? You need to have an answer for that. Okay, a good developers, good designer, they are not going to put anything that they don't need into the models unless they knew what they want, or unless they knew that they might need this in the future. Okay, you might not need it now, but if you put that right there, it may help in the future versions or in the next 2 years when they extend that. I think this is the way that we should do in order to accommodate the future changes or the future features. Another point I would like to make here is that when you design, and we will learn this together, right? When you design, try to find similarities between things. Okay, what are the similarities between human and dog? What are similarities between iPhone and a keyboard? What are the similarities between monitor and an air condition? All right. When you design things, when you go interview customer, when you go to the customer site, see how they work, what kind of documents they have, what kind of data they collect, you're gonna be overwhelmed by a lot of stuff, especially when you work in the real world. Your task is to find the similar features, find the similar characteristics, so that you can group them together. All right, and maybe if you remove all the attributes that you don't need, all the characteristics or features that you don't need, maybe the two things like a keyboard and an aircon could belong to the same class as well. And if they could be the same class, they're gonna make your life much easier. Updating, changing, all right, maintaining, gonna be much easier. Remember, find the similarities, not find the the differences. Remove the differences. Always find similarities. That will make your model and your program much simpler. All right, to summarize, this course, you will learn how to think object, how to design a software system with the object-oriented concept, okay, how to transform users' requirements into the design, especially UML, right? The course will be practical. You will have to design the actual software system from scratch, and you will also train or learn to be agile in the process. Well, let's discuss a little bit about practical here. This year, it is a little bit strange, okay, because the semester, the summer vacation is much shorter than than other years. So let's talk about the practicality a little bit here. In this course, you will learn to design a software system from scratch. All right. So what we normally do in OOAD course is that the students come up with their own project. Okay. You can design anything you like, right? You can design an EV station. You can you can design spacecraft, space station. You can also design the time machine, all right, something like this. Last semester, student designed a portal, all right, a portal service, okay, that you can send parcels or packets across in the globe, okay. Well, you can come up with any projects you like, okay, because what we do is that we just want to design, and you can design anything. But okay, normally we're going to do that in the lab sessions, but in this semester, because the semester start a bit earlier, all right, and some of you are still doing interns or still abroad, we are going to do this lab sessions in the second part of the course, basically after the midterm exam, when everybody is back in class, all right. So the first half will be focused mainly on the theory and concept first, and then so that therefore we are not gonna have lab sessions. But once after midterm exam, okay, we will start lab sessions and we start doing this together. And I will tell you in detail once we see each other how this the lab course would be conducted. All right. And this is our tentative outline. All right. Week 1, introduction and the big picture. We just did that. All right. Week 2 and 3, the requirement elicitation and modeling. Okay, we're gonna learn how to collect requirements from the customer and the users and how to transform that into a model. All right. And then moving on to week 4 and 5, okay, we're gonna do the scenarios, use cases, activity diagrams, and then we are going to move on to the user interface or UI and interaction between the human and a user and the machine, right, or your computer. These 6 weeks, okay, will be conducted online in video format like we are doing right now, okay, because some of you are still doing interns and still abroad, okay. And I believe midterm exam gonna take place around here as well. After that, we are going to meet each other in class. All right, the following class will be conducted in class. Week 7 and 8, we're gonna start modeling, okay, with classes, and then we're gonna week 9, we're gonna do the dynamic model and sequence diagram. I'm not sure we can do that in 1 week or not. Maybe we're gonna expand to week 10. Anyway, next session is architectural design, okay, and we're gonna follow by the design patterns. And after this, we are going to focus on your lab sessions. I will just give you some consultation. How can we improve your design and process? All right. Individually, you're working as a group, so they're gonna talk to each group individually. All right. So that's it. That is what we are gonna do in our course. Next point is the evaluation. Take a look at this. We don't have a midterm exam, right? We are going to conduct one final exam, all right, and that counts to 80% of the entire evaluation. Okay, to your grade. 20%. Okay, the other 20% is participation. You don't have to come to all classes. I don't mind if you want to come to class, if you don't want to come to class, all right? But if you do come, all right, you raise your hands, you ask questions, you participate in the conversation, all right, I will give you some points, all right? And each of you are going to get the maximum of 20 points. And these 20 points are quite easy to collect, all right, quite easy to get, because you can ask, you can answer. It doesn't have to be right or wrong, as long as you participate. You get something. You get 2 points, you get 3 points, you get 1 point. It depends on how complex or how interesting the question or the answer is, all right? But it is much easier than to get one from the exam, because in the exam you have to be correct and completely correct in order to get full score. In here in class, you can just talk, all right? Talk with us and you earn scores. Why do I do that? It is because in software industry, all right, nobody can solve everything alone. All right, there is no one best solution. No, there is no right solution. There is just a lot of solutions that you need to pick one. And sometimes you need to trade off. Okay, this solution is better. The other solution is better in the other aspect. All right, we're gonna pick this solution because we are focusing on this, but not focusing on that. All right, and with this nature, you need to discuss with your team a lot. Okay, software engineering, part of software engineering is communication. Big part, really. Okay, you could be super clever, but trust me, if you want to work on a big project, you cannot solve everything alone. So you need to share your knowledge. You need to discuss with your friends, your colleagues, in order to make sure that the solution you get is the best one, the most suitable one for your customers. Okay, so I always encourage people to discuss in class. The tricky part about this is that we can't discuss in the first half of the course. All right, so we're gonna do that once we see each other in class. All right, raise your hands a lot, talk a lot, and you just earn. These are textbooks that I would like to recommend. The first one is Applying UML and Patterns, an introduction to the object-oriented analysis and design and iterative development by Craig Lahman. This is quite old, all right, from 2004, but the contents of the book still cover what we discussed in class. I use it quite a lot, okay? And if you purchase this, not just for this course, for the next course, SDP, Software Development Process, you can also use this book as well, all right? I use the same book for both classes. And the other one is Agile Software Development, Principle, Pattern, and Practices by Robert Martin, okay? These two books are supposed to be easy to purchase in Thailand, right? I bought both of them in Thailand. So I believe you can do too. All right, this book going to be a little bit difficult to get. Okay, Object-Oriented Software Engineering Using UML Patterns in Java by Ben Brugger and Alan Detroit. This is the book from my own professor. Okay, he didn't pay me for advertisement, but well, what I teach here, what I learn, it also follows this book as well. And the last one is the System Analysis and Design by Kendall and Kendall. All right, this is quite recent. Okay, you can also buy this book in Thailand as well. All right, that's it, guys. Thanks a lot for joining me today. Okay, once I have the next episode of this series, I will post it on Discord. All right, so always follow our Discord channel. Okay, but for today, thanks a lot and see you later.